Dear students, firstly I will introduce myself. I myself Professor S. Chaubey, working as assistant professor in electrical engineering department of S&D College of Engineering and Research Center in India. So up till now, in the high voltage engineering, we are seeing what is the breakdown in the gases. It means how the breakdown occurs in the gases. What are the good properties of the insulating gases? So when you have seen in this, again we also see what are the types of the ionization. It means primary ionization or secondary ionization. We also see the difference between the primary ionization and secondary ionization. So now we will see, we also see what is the Townsend theory and what is the Steamer's theory. Also, we have seen when will the Townsend theory will be applied and when will be the Steamer's theory will be applied. Dear students, remember one point. P into D is less than 1000. What is P? P is the pressure and D is the distance between the electrodes. If it is less than 1000, then there is going to be uniform field, and in this case, Townsend theory is applied. But what will happen? If PD is going to be greater than 1000, then the non-uniform field is produced, and at this time we have to apply the Steamer's theory. So now in this lecture we will see particle exchange mechanism. What is this particle exchange mechanism? This is nothing but a type of the breakdown theory of the vacuum. This is nothing but the breakdown mechanism in the case of vacuum. So what is happening in the particle exchange mechanism? In short, I will give you some idea. Particle exchange. It means suppose in the cathode, two electrodes, electrical field is applied. Electrical field is applied. What is this? This is the emitter of the electrons. Where will they go? They will surely go to anode. On the bombardment of this anode, electrons on the anode, what happens in particle exchange mechanism? The positive ions, photons, are produced by this bombardment of the electrons. These are produced by the anode. Now positive ions, again where will they go? They will go to cathode. When they will go to cathode, they are bombarded, again they are releasing more number of electrons, and this process continues. So it is at the breakdown occurs due to continuous liberating of the electrons is called as the particle exchange mechanism. In short, I have told you what is a particle exchange mechanism. Now see here, particle exchange mechanism. In this mechanism, it is assumed that a charged particle will be emitted from one electrode under the action of high field, and when it impinges on the other electrode, it liberates opposite charge particles. Whatever opposite charge particles, what will happen? Positive ions and photons are released. Due to the ionization of the absorbed gases, these particles are accelerated by the applied voltage back to first electrode. Where they are accelerated, just I have told, they will accelerate to cathode. Where there is more number of original types of the particles. What are the original number of types of particles? Just I have told you, they are electrons. When the electrical field is applied, the cathode, due to this cathode, from this cathode, electrons, these are the original types of particles. It means just I have told you that more number of electrons are produced, and this is going to be becomes cumulative and chain reaction, which leads to vacuum breakdown of the gas. Vacuum breakdown of the gas. Here, particle exchange mechanism involves electrons, positive ions, photons, and the absorbed gases at the electrode surface. Involves what? Electrons, positive ions, just I told, photons, and electron present in the vacuum gas is accelerated toward the anode. Just I have told you that. Where will they go? Surely they will go to anode. And an impact releases, just I have told what? Just I have explained already. What will it release? It releases positive ions in the photon. These positive ions are accelerated toward the cathode and impact each positive B electrons, and each photon liberates D electrons. This is shown in the figure. You will see what was in the figure. See here, this is the cathode, this is your cathode, this is your anode. Electrons are bombarded on the anode. As the electrons are bombarded on the anode, what happens? These positive ions, see here, these positive ions and these photons are released, just I have told you. Where will they go? Surely they will go to cathode. Here, see here. They are going to cathode. Due to this again, more number of electrons or original particles are released, just I have told. More number of electron particles are released. These are the electrons. So this process is going to field mechanism. So it is going to be called as the field mechanism in the vacuum breakdown. Now, second theory, field emission theory. There are two types in the case of field emission theory. Remember, anode heating mechanism and cathode heating mechanism. Anode heating mechanism and cathode heating mechanism. What is that? Last point, don't on both ways. There is the anode is heated and there is the cathode. How that going to be? This theory states that electrons produced at a small micro position on the cathode due to field emission bombard the anode, causing a local rise in the temperature. What heating it means? There should be a rise in the temperature, and this releases gases and vapors into the vacuum cap. What they are going to be releasing? They are releasing the vacuum. They are releasing the vapors and the gases. These are going to be forming a vapor cloud. This is called, it means the formation of these gases and this vapor is called as the vapor cloud. You see the diagram. These electrons ionize the atoms of the gas and produces positive ions. These positive ions arrive at a cathode, increases the primary electron emission due to space charge formation and produce secondary electrons. What again? Secondary, what are the producing second again? Electrons are produced. The secondary electrons by the bombarding the surface. This process continues until a sufficient number of electrons are produced to give rise to vacuum breakdown. See, remember students, electrons are bombarded due to this one, heating of that one, heating of the anode. Due to heating of the anode, what happened? The temperature is going to increase. Due to temperature, again the vapor cloud is formed, and due to this vapor cloud, the breakdown of the gases occurring. So this is called as the anode heating. See the diagram. Vapor cloud here. The electrons emitted from this cathode, this is the anode. Electrons are emitted, and here is the vapor cloud is going to be formed. So now next one, we will see cathode heating mechanism. Just I have told you, either anode heating or the cathode heating. So in this mechanism, the cathode is heated. And what are the reasons behind it? The reason behind the sharp point on the cathode surface are responsible for the free breakdown current. Sharp points are occurring as available on the cathode surface, and due to this one, free breakdown current which is generated according to field emission process described. This current causes resistivity. Just I have told you. What is that? Both one, anode or cathode. Anode heating, cathode heating. It means if it is going to be heating, it means there is surely a rise in the temperature. So here, this is going to be the rise in the temperature. And it melts, this strip melts and explodes, thus initiating vacuum discharge. This mechanism is called as field emission, as shown in the figure. See here, vacuum cloud. Where, what in the last lecture we have seen, where the vacuum cloud is going to be formed? Across the anode, see the diagram. And where it is going to be the vapor cloud is formed, this is going to be vapor cloud is formed on the cathode. And this is different. So it is called as the cathode heating mechanism.